Okay, in chemical reaction, we need to do the basic character of amines. Basic character of amines. And this is very important because there will be variation in this. First of all, I'm going to write what is this basic character in amine. Basic character. Directly proportional to plus I. This is positive inductive effect. That means electron donating group, EDG. EDG, that means electron donating group. Electron donating group. You have heard of this I inductive effect in class 11, donating group, which is also directly proportional to plus R or plus M, you can say. And this positive is also electron donating group, and it operates through pi bond, and this operates through sigma bond. And we can also write directly proportional to Kb, which is base dissociation constant, and inversely proportional to pKb. And we can also write inversely proportional to minus I, that means electron donating group, and inversely electron withdrawing group. This negative sign tells us electron withdrawing group. Let me make it a small y, I in E. Electron withdrawing group. And this is also inversely proportional to minus R, we can write, and inversely proportional to K. K is acid dissociation constant and directly proportional to pK. So first, please do write it, and if you don't know the full form of this I, R, K, B, K, PKB, PK, just let me know. Ahmad, are you there?
Yes, sir.
Let me know when you are done with this. Ahmad, are you there? Please do respond.
Yes, sir.
So Ahmad, are you done with this?
Yes, sir.
Okay, Sakina.
Yes, sir, done.
Okay, so does anyone have any doubt in this I, R, KB, PKB, I, minus R, minus I, K, PK? Anyone have any doubt?
No, sir.
Okay. Now, I'm going to give you question on this C2H5 whole twice NH. First, let me know which one is 1 degree, which one is 2 degree. That means secondary. C2H5 NH. NH2, and then comes your C2H5 whole thrice N. So first of all, let me know, this is the question that I want you to do it in decreasing order of basic strength. And first of all, let me know which one is 1 degree amine, which one is 2 degree amine, which one is 3 degree.
Sir, the second one is 1 degree amine.
Very good. What about the first one?
2 degree.
Very good. And the last one is
Yes, sir.
3 degree.
3D.
Okay, very good. Now arrange this in decreasing order of acidic basic strength. So decreasing order of basic strength. You know what? Let me explain it first. So basically, if you are going to write the structure like this, C2H5, that means CH2, CH3 here, and CH2, CH3 here. And if you are going to write the structure of this one, you will be writing N hydrogen is there, as well as one hydrogen more, and then CH2, CH3. And everyone knows that alkyl group has plus I effect. Alkyl group has plus I effect. This is CH2, CH3. Then this is CH2, CH3. And then comes here on the left hand side CH2, CH3. So basically, the expected order, if you are going to do in directly proportional to plus I, you can see the third degree should be the most basic. It should be the most basic, the third degree, 3 degree. And then the second degree comes because it has support from two sides and it has support from one side. But in fact, when you do practically, you will get that in amine when you have R is equal to ethyl, then second degree is the most basic, then first 1 degree, and then 3 degree. Why it is so? So because on nitrogen, 3 bulky group, steric hindrance will be there and it will be less stable. That's why it comes at last. Is that clear? Is that clear?
Yes, sir.
So basically, this variation comes only not because of a steric hindrance, bulky group. It's also because of the solubility. It also because of the solubility, because as you can see, this will form more hydrogen bonding because it has two sides of hydrogen. So when you are going to dip this in water, it can form hydrogen bonding from two sides, and there is no hydrogen bonding, and it can form one side hydrogen bonding, and there is uh, plus I group from two sides. That's why it is most basic, then this, then this. So please do write it. Let me know when you are done with
Done, sir.
it. Very good. Now you are not seeing the variation only in this, you will be seeing the variation in methyl as well. You are also done with this, Ahmad?
Yes, sir. Thank you, sir. Done, sir.
Okay. Now I'm going to give you this CH3 whole thrice and then comes CH3NH2. Ahmad, let me know the degree of amine or degree of nitrogen here. So, I made a mistake. Just replace this, please. Just do something wrong there. Just replace this part C2H5 whole thrice. This is your C2H5. Just erase this C2H5 whole thrice and at last it is C2H5NH. Please correct this. First it is 2 degree, then 3 degree, then comes your 1 degree. 2 degree, 3 degree, 1 degree. Have you corrected it?
Just a minute, sir.
Yes, sir.
Okay, sir. Done.
Now I'm going to give you about this methyl. This is your 2 degree, this is your 1 degree, this is your 3 degree, and this is super primary NH3. So see which one is the most. In both case, whether R is methyl or ethyl, the secondary is more basic, most basic. The secondary is most basic, and in methyl it will be 1 degree and then tertiary comes, and after this NH3 comes. Because this nitrogen, all nitrogen has a lone pair and there will be a steric hindrance, that's why it is less. At last there is less steric hindrance, so in this way it will be. In the previous one, CH3 whole thrice is due to the solvation, it comes at second place. So you can easily remember this by, if you have methyl or ethyl, whatever it is, the secondary will be the most basic. In ethyl, you have at the second position it will be tertiary, and then at the third position it will be primary. But in methyl, the secondary again will be the most basic, then primary, and then tertiary. So please do write it. Let me know when you are done with this.
Sir, done.
Very good.
Done,
Now
sir.
I'm going to give you a question on this. You need to arrange this in decreasing order of Decreasing order of basic strength. Let me know when you're done with this.
Sir, done.
Okay, which one will be the most basic?
Sir,
The C2H5 to hold to NH.
The C, right?
Yeah.
So it will be
Yes,
the
sir.
second C. It will be the most basic C2H5 whole twice NH. Then which one will be the this one? Then comes C2H5 NH2. And after this, which one will be this or this? What do you think? See, this is your aniline, which we call it benzenamine. Benzenamine. This is your benzenamine. And you know that when you have a benzenamine and this is your ammonia, NH, is my video is clear or it's looking like, is it yellow and all? No, it's good. Okay.
So
Now,
it's okay, then sometimes it lags. So it's like you said, it's yellow or something.
might be my camera is not working good. Okay, you can see this is your ammonia and this is your aniline. So you know that in this aniline, this lone pair is in resonance. It is busy in resonance, but here it is free. It can donate easily, but this lone pair cannot be donated easily because it is in resonance. And since donation here is very easy, that's why after this ammonia will come and then benzene. Are you getting my point?
Sorry, sir, can I just explain that again? I didn't understand.
Yes. So what is basic strength? Basic strength basically the one which can donate the lone pair electron easily. That is called that will have the most basic. So when you are going to compare these two, so you know that in aniline the nitrogen, the lone pair on the nitrogen is busy in resonance, right? It is
Yeah.
conjugation, and that's why it will be busy in resonance, and this is not in resonance and it is free. So it can easily donate as compared to this because it is this is busy in resonance. Are you getting my point?
Okay. And sir, just what is the two dots above this N which you have made?
This is lone pair that represents
Lone
two
pair.
electrons. This is
Okay.
also lone pair. So it can donate easily because its lone pair is free here, but this this nitrogen has a lone pair which is in resonance. Okay, pi electrons these are. So that's why this is less basic and this is more basic. The one which can easily donate the electron are more basic. So please do
Okay.
write this.
sir, done.
Very good. So the chapter or the book of organic chemistry, biomolecules we have already done, right, Ahmad?
Yes, I believe so.
You believe only that the biomolecules is completed?
Yes.
Okay, so what we need to do in the first book, we need to deal with solution, D and F block, and chemical kinetics, right?
Yes, sir.
So which chapter we are going to start, solution or chemical kinetics? Let's go with chemical kinetics.
Okay.
So only this was left.
So for solutions, chemical kinetics and electrochemistry, should we go to the numericals first, or because those are important, right? For this type of questions,
Very, very
lessons.
important. You should do numerical as well as the theoretical part.
Okay.
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 So we are going to deal with the chemical kinetics. Sakina, have you studied this chapter before?
Yes, sir.
Okay, that's good. Okay, let's start this chemical kinetics. And basically, first of all, I'm going to introduce this chapter. Basically, what does this chapter is going to deal with? So basically, this chapter is going to deal with the rate of reaction. It's going to deal with the how much time a reaction will take and the mechanism behind the reaction. So you can write a small point about this, and that is basically, write with me, the branch of physical chemistry which deals with the rate of chemical reaction, rate of chemical reaction, and the mechanism by which the reaction proceeds. This is what we are going to learn in this chapter, and that comes under chemical kinetics. So first of all, I'm going to introduce this rate. So what does this rate of reaction means? So you can write a rate of a reaction is defined as change in concentration of concentration, either concentration, and if it is in gaseous state, then we are going to take pressure of either reactants and products per unit time. This is called basically a rate. That means basically, you know that when you are going to start a reaction at T equals to 0, the concentration of reactant will be something, but after some time it will be decreasing. So the change in concentration of reactant upon the time taken to change, that is called the rate. Or if you are going to talk about the product, you know that before starting the reaction at T equals to 0, you will have zero concentration of product because the reaction is about to start. But after some time, you will have something in product, concentration of product. So you are going to calculate the change in product. That means final product minus initial product upon time taken to change. That is also the rate. So we define rate for reactant as well as product. So here I can write the rate is equal to change in either concentration, or if it is in gaseous state, so we deal with pressure of either reactant or product, R for reactant and P for product, divided by time taken, divided by time taken. And there will be a plus sign as well as minus. There will be plus sign as well as minus. So we can also write here plus minus delta C, that means change in concentration upon delta T, and this T is concentration for product as well as reactant. And what does this positive sign tells us, and what does this negative sign tells us? So positive sign is for product because it is increasing with time, product because it is increases, and negative sign is for reactant because it is decreasing with the time. You know that when you are going to do the reaction, you will have something in reactant, but the product is zero. But after some time, you will see that the reactant decreases and product increases. So this negative sign only tells us about the increasing or decreasing concentration of reactant as well as product. Are you getting my point, both of you?
Yes, sir.
So please do it. Let me know when you are done with this. Are you done with this, Sakina and Amar?
Yes, sir.
So almost done, sir. Just 2 minutes. Done, sir. Thank
Very good. Now, can you calculate the unit of weight? I had given you the formula. Calculate the unit of weight. This unit of weight. Please do it. Sakina, is there any answer? Ahmad? So you can see unit of rate. Change in concentration. The unit of concentration, that is molarity. So it will be mole per liter upon time, that is seconds. So the unit of rate will be mole per liter per second. Are you getting my point?
Yes, sir. No, good.
Very good.
But there is also change in concentration, then pressure of
Yeah, if you are going to deal with pressure, then it will be pressure is the unit atm per second. So it will be atm per second, or if you are going to write it in the pressure of unit, you are going to take bar, it will be bar per second.
okay.
Okay, so there is slash, change in either concentration of reactant or product, or change in pressure of reactant or product. Are you getting my point?
Yes, sir.
Okay. So can I change the slide?
Just a minute, sir.
So I'm going
Yes,
to
sir.
plot a graph. I'm going to plot a graph. Please do let me know. This is what I am going to do. It is like this. And then it is like this. Now the graph is basically between concentration versus time. Which one is for reactant and which one is for product? The green one is for reactant or product, or the blue one? Reactant or product? Sakina, can you tell me?
So green is the product. And
Green is the product. Very good. This is basically for product because it started from 0. And this is for reactant because it started from some. So basically the green one is for product and this is for the reactant. Initially the reactant is something, it will have some value, but the product is 0. Sakina, are you there?
Yes, sir.
Okay, can I change the slide for this?
Yes, sir.
yes, sir.
Okay. Now see, we are going to deal with. So if a reaction is taking place, that is reactant converting into product, if you will see, Alan, are you there? You just joined. So at t equals to 0, you will have something reactant of concentration of reactant, but the concentration of product will be 0. At t equals to t dash, let's say, the concentration of reactant will decrease and there will be some formation of concentration of product, right? That's why you can see the graph that I had plotted, it will be like this. This is for product because it started from 0 and it will have some value, and the reactant has already some value which is decreasing. So this is for reactant. Now what I want to say is that there is a term that we use here, that is the rate of disappearance, and you know what is this, what does disappear means. So basically you can see with the time the concentration of reactant decreases or starting disappear, so we use this disappearance for reactant. So I'm going to write here rate of disappearance, rate of disappearance of, let's say an example, A is converting into B. So for this reaction, I'm going to write, we will use this disappearance term for A because it is reactant. So it will be minus change in concentration of delta A upon delta T. Why we use negative? As I already told you, this negative sign is used for reactant because it decreases. And when you are going to write for product, it will be a rate of appearance because it is started from 0 and it will have some value. That means it is increasing basically. It means that it is increasing. So it will be a rate of appearance, or we write appearance, or sometimes we will be using this rate of appearance or formation of D. And we put positive sign for product, and it will be change in concentration of product upon delta. Alan, are you there? Please do respond so that I will be able to revise or give a quick review of today's class. At least do respond in chat box. Sakina and Ahmad, let me know when you are done with this.
Done, sir.
Okay.
Done, sir.
Ahmad, what about you? Okay. Okay. If I'm going to give you a reaction that is N2 plus 3H2, that will give you 2NH3. And if I'm going to ask you, write the rate of appearance and disappearance of this reactant and product in this reaction, can you do this? So what it will be, this is reactant, there are two reactants, so I'm going to write for the N2. So it will be basically the rate of disappearance. We use this disappearance for reactant. The rate of disappearance of first N2. So it will be minus delta N2 upon delta T. Now for the next reactant, again rate of disappearance of H2, that will be minus delta H2 upon delta. Then come for the after reactant, then come for the product. Rate of, for reactant we for product we either use appearance, or sometimes there will be this term as well, rate of appearance or formation of what, NH3, because this is the product. So I'm going to put positive sign, and it will be delta NH3 upon delta. So this is how we write rate of appearance and disappearance as well. So I think you can write this expression for any reaction that you are going you have been given, right?
Yes.
Thank you. Thank you for the response. Sakina and Imad, let
Sir,
me know when
done.
Imad, you are
Done.
also done with this. Okay. Now see the next topic that is basically write the topic that is your rate of reaction in terms of stoichiometric coefficient. This is your topic, rate of reaction in terms of stoichiometric of a chemical reaction. Of a chemical reaction. Now see, if you have given a reaction AA plus BB, that is giving you CC plus DT. Now the important point is that this small d, small c, small b, small a is the coefficient or stoichiometric coefficient of A, B, C, D. Are you getting my point?
Yes, sir.
Now, if you are going to write the rate of reaction, the previous one was a rate of appearance and disappearance, but when you are going to deal with the rate of reaction, it will be equal, like rate of reaction will be equal to whatever is the coefficient, it will come in denominator. It will come in denominator. First of all, please listen to me very carefully. The coefficient will come in denominator, and as you can see, this is your reactant, so there will be negative sign, and change in concentration of A upon delta. Then this will be equal to whatever is the coefficient that will come in denominator, and there will be negative sign because it is a reactant, and then change in concentration of B upon delta. Then there will be equal, and since it is product, so you are going to put positive. Then look for the coefficient, C is the coefficient, so it will come in denominator, and then change in concentration of C upon delta. Then again equal to, it is product, so I'm going to put positive sign, and then 1 by D, and then change in concentration of D upon delta. Are you getting my point?
Sorry, sir. Can I just repeat it again?
Yes, why not? Whatever see, this is reactant, product. You can easily recognize whether which one is reactant and which one is product, right? Ahmad?
Yes, sir.
Now, and you also know that reactant decreases and product increases. And for reactant, we use negative sign because it decreases, and for product, we use positive sign because it increases, right?
Yes, sir.
Now, if you are going to write the rate of reaction in terms of stoichiometric of a chemical reaction, so whatever is the stoichiometric coefficient, it will come in denominator. It will come in denominator. As you can see, I'm going to take another example. N2 plus 3H2, that will give you 2NH3. N2 plus 3H2, that will give you 2NH3. Now, if you are going to write rate of reaction, ROR, that will be equal to, first of all, I'm going to write for this negative, and then what is the stoichiometric coefficient? 1 it is, so 1 by 1, and then delta N2 upon delta T. Then it will be equal to, since it is also reactant, so it will have negative sign, and whatever is the coefficient, it will come in denominator, and then change in concentration of delta H2 upon delta T. Then equal to, this is your product, so I'm going to put positive sign, and whatever is the coefficient, it will come to denominator, and then change in concentration of NH3 upon delta T. Are you getting my point?
Yes, sir. Got it. Thank you.
Sakina, Alan,
Yes, sir.
Alan, please do respond if you are getting it or not. You don't respond at all. Let me know when you are done with this so that I will give some questions to write the rate of reaction, and then we will move to the next topic.
Sir, done.
Thank you.
Done, sir.
Very good. Let me know when you are done with this. Sakina, are you done with the first one? You shouldn't take this much time for this small question.
So the rate of disappearance.
No, we are going to talk about rate of reaction, not disappearance. Are you getting my point, Sakina?
Oh, yes, sir.
No problem. If you have done that, please do this also. Amar,
Yes, sir.
what about you?
So for the first one, sir, I'm getting some delta
See,
two
I'm
by
going
two
to
delta.
write it. Just let me. ROR will be equal to, first of all, it is reactance, so I'm going to put negative and then 1 by 2. Delta is to 2 upon delta. This will be equal to, this is negative, and then what is the stoichiometric coefficient? 1 it is. So whether you can write it 1 or not, that does not matter. It will not affect it. Now, this is product, so I'm going to put positive sign, and then what is the coefficient to air, and then delta is so 3 upon delta. Have you done it correctly? Yes or no? Alan, Sakina,
Yeah, yes, sir.
have you done it correctly?
Nice, bro.
Okay. Sakina, let me know when you are done with this, please. Everyone done with this?
Yes.
Very good. Sakina, what about you? I'm going to write the answer.
Yes, sir.
Okay, just match the answer. Then for this rate of reaction will be equal to negative 1 by 2. And then delta N2O5 upon delta T. Then it will be equal to positive 1 by 4 delta NO2 upon delta T. That will be equal to positive 1 by 1 if you want to write delta O2 upon delta. Please match your answer. Now, if you are going for this reaction, rate of reaction will be equal to minus 1 by 4 delta A upon delta. Then it will be equal to minus, since it is also reactant, 1 by 1 delta B upon delta. Then it will be equal to plus delta 1 by 2 delta C upon delta, change in concentration of C upon time taken, plus 1 by 3 change in concentration of D upon delta. Now, if you are going for this ROR, that will be equal to negative 1 by 1 delta BrO3 minus upon delta. Then again, if you are going for this negative 1 by 5 delta Br negative upon delta, change in concentration of Br negative, then minus 1 by 6 delta H plus upon delta. Then it will be equal to, this is product, plus 1 by 3 change in concentration of Br2 upon delta. Then it will be equal to plus 1 by 3 change in concentration of H2 upon delta. Is that clear? Is it all correct? It should be correct because it's very easy.
The fourth one was wrong.
Okay, so please correct it. Sakina, what about you?
Sir, my second one is wrong. The rest all is correct.
Okay. If you still have any doubt, just ask me.
So for the fourth part, sir, here 6H plus is the product of the reactant here? Because
One. This
yes, sir.
is on the left hand side. It is reactant. Is there any other doubt? Are you getting it? Before reactant, left hand side, it is reactant.
Is just can you just explain the answer again, sir? Just
What is the coefficient here? 1, so it comes here.
yeah.
And the rest part is additive. What is the coefficient 5? It is in denominator. Negative because it is reactant. Change in concentration of Br negative upon delta T. This is 6, coefficient comes here. Change in concentration of H plus upon delta T. This is your product, positive, and since there is 3, that comes in denominator. Change in concentration of Br2 upon delta T. Then again this.
Okay. Yes, sir. Okay.
Can you change the slide?
Yes.
Everyone. Now come to the next topic, that is rate law. What is rate law? So first of all, I'm going to write it. Please do write with me. Rate law. So basically, it is an experimental expression. The experimental expression of rate in terms of concentration of reactant. First of all, this rate law only deals with the concentration of reactant, not the product. Is known as a rate law. And the expression of from this, that is called a rate law expression. So basically, what is the rate law? So the experimental expression of rate in terms of concentration of reactant. This part is very, very important. Rate in terms of concentration of reactant. That is basically your, what we say, rate law. Is that clear, everyone?
Yes.
The rate law is only defined for the concentration of reactant, not product. So if we have a reaction AA plus BB, that will give you anything, that is product CC plus DD or anything. We don't need to deal with the product, we only need this reactant. So a rate is directly proportional to the concentration, product of the concentration raised to power something. It will have power something, and this power is basically calculated experimentally. This power is calculated experimentally. Is that clear?
Yes.
So please do write it. This is what I want to tell you. That rate is directly proportional to a raised to the power x and b raised to the power y, and rate r will be equal to k into a raised to the power x. This square bracket represents your concentration. This square bracket represent your concentration. So this is the rate law express. This is the rate law express. Now what is this k? K is basically your rate constant. K is basically rate constant, and this rate constant only depends upon temperature. Now what is x? X and y is experimentally determined. It is experimentally determined. And this x or y, may or may not be equal to, may or may not be equal to A or B respective. If you are going for, or we can write, its stoichiometric coefficient. So it's very easy to understand that this power may or may not be equal to its stoichiometric coefficient. That we will know after experiment. Is that clear? Let me know when you are done with this. Are you done with this?
Yes.
So basically, again, I'm going to repeat it. What is rate law? Rate law expression is basically in terms of concentration of reactant, and that is your rate law. So according to rate law, rate is directly proportional to the concentration of reactant raised to the power something, and this power is determined experimentally. So this is your basically rate law. Now, right topic, that is order of a reaction, and after this you will get more information about rate law expression. Order of a reaction. These both are connected. So what is order of a reaction? So write with me. The sum of power of concentration. The sum of power of concentration of reactants in rate law expression. In rate law expression is known as order of reaction. Order of a reaction. So it's very easy to understand that if we have a rate law expression, that is k into a raised to the power x into b raised to the power y. So this power, what we are going to talk about, this power is basically, if you are going to sum it, that means basically if you are going to add this x plus y, basically the order of reaction is denoted by n. So you will be getting the order of reaction. So here x is order of reaction, x is order of reaction with respect to A. With respect to A, because it is the power of concentration A. Y is order of reaction with respect to B. But when you are going to talk about N, N is order of reaction. It is order of reaction. N is order of reaction, or we can say overall order of reaction. So if you have given rate law expression, you are going to add the power of the concentration in rate law expression, you will get the order of reaction. Write a point. Order of reaction may be positive, negative, zero, or even fraction. Let me know when you're done with this.
No, sir.
Very good. Everyone done with this? Sakina?
Yes, sir.
Very good. Now I'm going to give you a question. Calculate. Overall order of reaction or order of reaction means same. Calculate. Overall order of reaction. Which has rate expression like it is given that the rate is equal to k into e raised to the power half and b raised to the power 3 by 2 be given as the rate is equal to k into e raised to the power 3 by 2 and b raised to the power 1. The rate is equal to k into e raised to the power 2 and b raised to the power minus 2. Please let me know the order of reaction.
Sir, for the first one, is it 2?
Yeah, it is. Just hold on a minute. I'll do that. Sakina, are you done with this?
Sir, I'm doing.
Okay, have you done the first order of reaction, that is n is equal to power sum of the power of the reactant or concentration in rate law expression, that will be 1 by 2 plus wait a minute, 1 by 2 plus 3 by 2. You are going to take LCM, so it will be 2, and then 1 plus 3, it will be 4 by 2. that will be equal to second order. Okay, I want to take an extra class on Friday. Who is up for the extra class? Because we have to cover 3 more chapters, including this.
Sir, again, sir, the timing will be important for me, sir, because I have one more tuition on Friday this week.
At what time? Is it fixed, the time?
Sir, Saudi time, I'm saying, 5 to 6:30.
5 to 6:30. That means Indian time.
No, Saudi time, sir.
Okay. 5 to 6:30.
Yes, sir.
So here it will be 2:30 to 4 p.m., right?
No, 5:30 p.m. here, Saudi time. So it is 8 o'clock, sir. 8 o'clock of Indian time. 8 o'clock to 9:30 Indian time.
Indian time. That means you are free at 6:30 Indian.
Yes,
4 p.m. at 4 to 5:30 Saudi time. You can take that class, right?
yes, sir.
Okay. What about you, Sakina?
Sir, I am free.
You are free. Thank you. Alan? So I'm going to take an extra class. Please do let me know about this answer.
I'll let you know, sir, if there's any changes regarding my Friday's class.
Okay. No problem. What about the B answers? Answer for the B order of reaction and C.
1/2.
So it's also very easy. N is equal to 3/2 plus 1. That is not 1/2. You are going to take LCM and here it will be 5/2 orders. You are going to add, it is 3/2 already 1.5.
Yes,
Are you getting my point? What about
yes,
the
sir.
C?
Minus. So here I didn't understand, sir, because 2/2 minus 2/2. So 1 minus.
How it is minus 2/2? Where is 2/2? Is there any 2/2? You are going to add the
Okay, okay.
power now. So you can see
Yes, yes, yes.
that here it is plus 2 and here it is minus 2. You need to add the power. So you can see
Okay.
it is 2 and plus minus minus 2. That means it is 0.
0.
That means the
Okay.
last one is 0 order reaction. Order reaction.
Okay. Got it.
Sakina, have you got it?
Yes, sir.
Okay. So there is a homework for you. Calculate unit of rate constant. That means K for the 0, first, second, and nth order of a reaction. Nth order of a reaction. The unit of rate constant varies when the order of reaction varies. Okay.